Thank you so much, everyone. So yes, this is the online presentation. You can let me know if there is any trouble or if you cannot see the screen or audio. So I will start. My name is Asma Fariha. Me and my co-author, we are from Ontario Tech University, Canada. So I am going to present my paper today that is titled as Towards Requirement Specification Collaboration Forum for Embedded Software System. So at the beginning of my presentation, I will talk about the objectives and research gaps that basically motivated us with this research idea. Then I will explain our approach because this is a work in progress paper. So I will show an illustrative example that will help us to understand how this approach is expected to work. Finally, I will list out all the necessary steps to implement this current idea. So all of us already know that requirement engineering, that is the beginning step of software engineering lifecycle. This is really a very important step of software engineering lifecycle. And if there is any gap in the required engineering process, then that can result in incorrect product or in system failure. This is already an established fact that many of the system level failure basically are the result from improper or poor requirement engineering. Now, there are different challenges in the current requirement engineering practices that researchers are looking into and finding the solutions. Sometimes the stakeholder raise some requirement that can have conflicts with other requirements raised from other stakeholders. Some requirements may have missing specification that makes it harder to do the proper analysis and then the verification. Then there can be lack in stakeholders communication because the vast amount of stakeholder, they can belong from different geographic location, and sometimes it makes difficult for very effective communication and collaboration. All of these can basically result in incomplete analysis. That being said, it is even more complex in embedded software because embedded software is an integral part of embedded system, and that system also has the hardware or physical components. Nowadays, embedded systems are everywhere in our life, starting from the mobile we use or the car we drive. Embedded software has unique characteristics that makes the requirement engineering phase a little bit different than the general software systems. So the safety critical requirements or the real-time response constraints of embedded system that makes the requirement engineering process a little bit complex. Also, these embedded software are deployed in a very constrained physical system that can basically limit the memory or processing time. Also, the functional requirements of embedded software are as much important as the functional requirement. There are also very industry specific requirements or standards, such as the standards for avionics will vary from the standards for cars. Now, we are focusing on the requirement analysis and negotiation phase. So the analysis phase basically comes after the requirement elicitation, and the requirement engineers, they work towards finalizing the specification of requirement. Requirement specification basically lists out all the properties or characteristics, dependencies, or prerequisite and restriction or limitations. So to finalize this list, we need effective stakeholder engagement that can also help us to solve the conflict early or identify critical requirement and the critical specification for these requirements. Now to conduct this phase, if we are to select the stakeholders manually, that can generate errors. Because with the complex system, there are a huge list of requirements. Also, there are so many stakeholders involved in this process. Also, if the requirement engineers are to compile a vast list of the feedbacks from stakeholders, that is not only require extensive amount of time, also that can result in error. So different research has looked into this problem and have come up with different ideas. Starting from Herrera and the team, they have proposed a semi-automated recommendation system So this is a forum-based collaboration platform for the stakeholders that basically is proposed for general software engineering. This process use the natural language processing to collect the forum from the elicited requirements. So the problem with this system is that this works with the natural language processing, and that cannot be maybe applicable for all the systems, or for this example, like the embedded software. Then the similar idea was proposed in requirement forum. So it's a 6-step process and was proposed for open source project. This actually needs the requirement to be collected in a template. And the problem with that is not all the stakeholders may be enough skilled to use such sort of templates. In European research project, there was a requirement collaboration forum proposed for the stakeholder across different geographic location. But this method basically did not work towards automatic identification of stakeholders, rather that involved manual process. Then StakeRare, this is a collaborative filtering approach, and this approach basically needs explicit rating from the stakeholders to generate the advanced recommendation. Finally, the OpenRec, this actually used the content-based recommendation to help the requirement manager to find suitable stakeholders to implement those requirements, and this used the supervised learning. So what are the challenges still existing in this domain? Basically, embedded software requirement modeling is done in a different way. As I already said, this is the part of a physical system, and the software system components are also involved. So the requirement elicitation is done at the beginning, and then the specific requirement for embedded software is passed over in a modeling language, mostly the SysML modeling language. So if we have to now adjust with the existing methods, then there are so many overheads related. Either that has to adapt the natural language processing, or this natural language processing requirements has to convert in the modeling approach. So to use that content or collaboration-based approaches, the stakeholder need to give explicit input that also can bring extra overhead to the system. Also, the algorithms are mostly supervised algorithm, and it requires a huge number of label data set, and that can be very difficult to find because of sometimes the confidentiality issue. So we have come up with this idea to propose a collaborative platform, which we call the forum for stakeholders, where stakeholders basically can give their opinion and feedback on the specifications or limitations that is already listed. And then comes the question how to identify the relevant stakeholders. That will involve 2 steps. So the primary one will be from the existing information we have from the elicitation stage, and then there will be advanced automatic recommendation. So we will use the specific version of SysML modeling language. So SysML modeling language basically present in a formal way what is elicited in the beginning stage. So the regular SysML modeling language basically will properly represent the link between requirements, but it is very hard to implement the traceability. So we will use the specific version that is titled as SysML for traceability. This version will contain some additional profile tag. We can use these tags for our app. And then for the advanced automatic recommendation, we will use collaborative denoising autoencoder. This is a deep learning based algorithm. So this algorithm basically saves the extra work because this does not need any external or extra input from the stakeholder. Rather, it will use the existing information that we have. So how this autoencoder process works is that I will give an example for a movie recommendation system. So if the user already liked the movie, then the vector will be 1, or if the didn't like it, so the vector result will be 0. We will use this sort of idea with our system. to generate the input vector for our recommendation system. So this is overall the structure of our proposed approach. This will start from the forum generation. And then in the next step, this is the initial stakeholder assignment, and then the advanced recommendation for the stakeholders. I will explain all these steps in details now. So the forum creation will use information from SysML for traceability diagram. As I said, this will have the additional profile tag. So primarily, all the direct requirements will be converted to a forum. As I already said, so this forum will contain the specification and restriction or other information, relevant information, and stakeholder will be able to raise their concern or give their input in this forum. So how this forum will be generated is that the name of the forum will be the name of the requirement from the diagram, and then relevant ID. Also, we can assign the stakeholder who basically raised this requirement or who basically own this requirement. So this all information can be found from the SysML for traceability. The other link that will be used is the derive request or refine association. So this derive request or refine association connect the detailed specification for the original requirement. So these are not the original requirement in the SysML for traceability diagram. This will be the more detailed specification. So we can also combine them in a forum. Then this is the first step of assignment from stakeholder to the requirement. So again, in this step, we will use the SysML for traceability diagram, and the profile tag will contain the requirement owner or who basically proposed this requirement. And this is direct mapping from the requirement diagram to the forum for stakeholders. So there is no much algorithm or processing involved in here. This is the direct step. Now we want to know who are other relevant stakeholders for this requirement who can contribute in the analysis phase. So that is the automated recommendation step we are proposing. This step basically will involve collaborative denoising autoencoder algorithm. And this algorithm will need the input vector. This vector will be constructed by stakeholder requirements interaction log. So this algorithm considered this initial input vector as a partial or corrupted set of data and generate the complete set of data through the internal processing. This step will involve three different sets. The first step, that is the set of user, in this case, the set of stakeholder. The second step is the set of requirements. And the third set is basically the log, user requirement interaction log. So here, like for stakeholder EU, for the requirement I, value will be 1 if this requirement was raised by this specific stakeholder or owned by this specific stakeholder. So again, this list or this vector will be generated basically from the SysML for traceability diagram. So this does not need any extra work or input from requirement engineer or stakeholder. Now, when we have this information, which user raised or owned this, which requirement, we have a complete list of vector. This is the input vector Y. So input vector Y, the dimension for this vector is number of stakeholder multiplied by the number of requirement. And there will be L number of non-zero values. That means all those direct link between the requirement and the stakeholder who raised them. So once this input vector is passed through the collaborative denoising autoencoder algorithm, then we get the output vector. So this output vector will have more non-zero values than the input vector. So those additional non-zero values are considered as the complete set of recommendation, and that is basically the advanced recommendation for the stakeholders to requirements. As I said, this is our example So this will be the SysML4 traceability requirement diagram, which we can use, and I will show how the expected results can be generated from here. So there we have, this system is for the picture taking module for a drone system. And there are three direct requirements here. First one is the taking picture, then saving picture, and transmitting picture. So this will be generated into individual forum. Now, there are other requirements you can see in this diagram, that is peak taking duration and compact flash. But these will not be considered as a standalone or original requirement. Rather, these are connected with a define and derived request relation. So this will be added in the taking. So the first one, picture taking duration. This basically defines further about the taking picture requirement. So it will be added in the relevant forum. Same for compact flash. So this basically says where to save the data and basically, explain the saving picture requirement. So this one will be added to the relevant forum. Now, this is the generated recommendation. So at the beginning stage, we have taking picture and saving picture. Due to space issue, I haven't kept the transmitting picture requirement. These two will be enough to understand what we are looking into. So for the taking picture, we have also the requirement connected picture taking duration that is added as a specification to this requirement. And in the original diagram, these two had the stakeholder 1 and 2. So the first assignment from stakeholder that will be generated to stakeholder 1 and 2. Same for saving picture. So in the original diagram, saving picture has stakeholder 2 and the specification compact flash that has stakeholder 1 and 3. So basically, sorry, stakeholder that is just, yeah, so stakeholder 1 and 3. Now, when this initial set of information are generated, now it's time for the advanced requirement, advanced recommendation generation. So because stakeholder 3 is missing in the taking picture forum, but stakeholder 3 had some opinion on these other requirements and may have some important information for the taking picture requirement as well. But stakeholder 3 does not know about the taking picture requirement, or taking picture requirement basically may miss some specification restriction information from stakeholder 3. So once this information is passed through the collaborative denoising autoencoder algorithm, the advanced recommendation from taking picture to stakeholder 3 should be generated. So as I said, this paper is a work in progress and still need the implementation. So we have this illustrative example to understand what we are proposing here. Now, we need the future work to implement this process. For this SysML for traceability, not every system already has this modeling. So to test this approach, we need a system that from the very beginning will do the modeling using SysML for traceability. Otherwise, the necessity information will be missed and this approach cannot be implemented. Stakeholders should have a profile in this system. So the first thing will be the direct assignment, like which stakeholder basically own which requirement, and also the additional recommendation information. So that will be summarized in a stakeholder profile. Then for the evaluation, the recall metric will be basically used because that can define how many predictions were correct. So this approach also can be used for general software engineering, but there is an adaptability issue because most of the general software engineering use different modeling approach for the elicited requirement. Mostly those are in natural language. So there has to be like more work done to make the adaptability working. And also we can use other information for the stakeholder to generate this recommendation. Like if the stakeholder is expert in system or in user experience, those sort of information. But that will involve some extra work, such as input from the stakeholder or input from the requirement engineer to generate some profile information for as an input vector, or we may need some other algorithm to work with those data. So these are need the further exploration. Now I will summarize what we have proposed. This system basically represent a collaborative platform for the stakeholder, where stakeholder can contribute with their feedback and input, and then requirement engineer will have a centralized place from where they can see the feedback and solve any conflict or compile all this input. This system should be more time efficient and minimize the error, because the recommendations are generated is a proactive recommendation, and all this information is taken from the requirement modeling diagram. There is no involvement from the requirement engineer or the stakeholders in between the process. This also should reduce the the extra work for the requirement engineers. Now, I already said this will need the SysML4 traceability diagram. The other format, that the basic SysML diagram, SysML2, will not work for our proposed approach. And then the collaborative denoising autoencoder will generate the advanced recommendation based on auto stakeholder and the requirement interaction log. So that was all from me. Now, if there is any question, I would love to attend that. And if I cannot hear properly the questions, then I may need our session chair's help. So that's all from me.